We'll now look at something about the pressure due to the liquid as well as pressure due to the atmosphere. Here, whenever you take some liquid in a container, this liquid will exert force on all the walls of the container. This force is exerted on some area of cross section. Therefore, pressure is always exerted on the container, on the walls of the container. So here, pressure is exerted on this vertical wall and this vertical wall as well as this bottom surface. Here, this pressure is compensated by the strength of this wall, so that the pressure exerted on the wall is balanced with the pressure exerted by the wall, on the wall, by the wall. Liquid is exerting pressure on the wall is exerting pressure on the liquid, which is getting balanced. So it is stable. Whereas coming to here, the liquid column is exerting pressure on the bottom and at the upper end, it is open to the atmosphere. Here, this entire liquid exerts a force on the bottom. So, the pressure exerted by the liquid is a function of height of the liquid. That is, pressure can be calculated here as P is equal to H rho G. Rho is nothing but density of the liquid and G is nothing but acceleration due to gravity. And rho is a constant because that depends upon the nature of the liquid, whereas G is also a constant, that is on the surface of the earth it is 9.8 meter per second square. So these two are constants. Therefore, pressure depends upon the height of the liquid column, only height on the liquid column. So pressure depends only on the height of the liquid column but not on the volume of the liquid as well as the shape of the container. So whatever may be the shape of the container, if the height of the liquid column increases, then obviously the pressure increases because P is directly proportional to H. Here we can take P is a function of H, that is P is directly proportional to H. That means height of the liquid column increases, the pressure also increases. It depends only upon the height of the liquid column but not on the volume as well as the shape of the container. And to know this in a clear manner, we have taken 4 different vessels over here. In these 4 different vessels, we have taken a liquid up to the same height. Height of the liquid column is same in all the cases, but when you are looking into the volume of the liquid, here the volume of the liquid differs. The volume of the liquid here is different from here and is different from here and is different from here. So, the quantity of the liquid is different but the heights are same. That is the reason pressure exerted by this liquid on the bottom surface is same as that of pressure exerted by this. Therefore, the pressures due to the liquid columns on all the bottoms of the different shaped containers will remain same. Therefore, P1 is equal to P2 is equal to P3 is equal to P4, meaning that pressure exerted by all the liquid columns are same because they are all at the same height. So here we need not consider about the shape of the container. These are the different shaped containers, but height of the liquid column is same. So make a note that pressures are depending upon, liquid pressures depend only upon the height of the liquid columns and nothing else. So shapes are immaterial for us, volumes are immaterial for us. We need to bother only about the height of the liquid column in a container. So this is what about the pressure due to the liquid. So liquids exert pressure on the container, on the bottom of the container, that depends upon the height. Now, atmosphere also exerts a pressure on the surface. Here, this is the Earth's surface and Earth is surrounded by the atmosphere. So obviously air is surrounded to this. So atmosphere containing the air. So if at all you consider a unit area of cross section on the Earth's surface, then from this unit area of cross section to certain extent there exists a air particles, that means atmosphere, and beyond that there is no atmosphere. That is what we have written here. Here there is no atmosphere, but for this per unit area, if at all you go vertically to certain extent, the air exists. Therefore, in this unit cross-sectional area to how long the air consists of, that air weight you have to take here. Weight of the air divided by area of cross-section is, if you are taking unit area 1 meter square, or if you are taking some other area, then you will be taking that area. Obviously, you are getting weight per unit area of cross-section. So, that gives rise to the atmospheric pressure. That means pressure exerted at this particular point due to the atmosphere. That is what called as the atmospheric pressure, which can be given as PA is equal to, that is atmospheric pressure is equal to, this is the value which has to be taken as a constant on the surface of the earth. This is generally measured by using an instrument called barometer. So barometer is the instrument which is used to measure the atmospheric pressure. So that is the reason, one thing you need to understand, as you are going to the heights, pressure decreases. Therefore, inside our body the pressure is high, outside the body the pressure is less. That is the reason when you are going to the heights, nose bleeds because of this pressure imbalances. So as you are going to the heights, pressure decreases. Whereas in case of the liquids, as you are going to the depth, the pressure increases. So inside the sea, when you are getting into the sea, as you are going to the depth, the pressure is increasing. Whereas you are going to the heights from the surface of the earth, the pressure is decreasing. So these are the points you need to understand about the pressures due to the liquids and atmospheric pressures.